Algebra students, we're going to jump into 3.1 example 2, and now we're actually going to sketch the graphs for the given situation. So remember from example 1, they gave us the situation and had us match up the graph to that situation. Now we're not going to have any help. We're going to sketch a graph and then determine whether that graph should be a continuous graph or a discrete graph. So let's talk about it for just a second. Continuous just means I would connect my points together. That means all the points in between the graphed points are included in the answer. Or with a discrete graph, we're saying, no, we're not going to connect the points on this graph because these are the exact answers that they should be. There's no in between. All right, so let's look at our example. We're in example 2A. And here's our situation. Simon is selling candles to raise money for the school dance. For each candle he sells, the school will get $2.50. He has 10 candles that he can sell. Okay, now as you're planning this out, you know how many candles that he sells. So the idea is if you can create kind of, in this situation, because we have numbers, they don't always have numbers, but when they have numbers, you can get a general feel for how things go. So number of candles we'll put over here, and then we'll make this total money that's being earned as each candle is sold. Okay? So remember, if he doesn't sell any candles, he's not going to make any money for the school, okay? If he sells one candle, the school will get $2.50. If he sells 2 candles, the school will get $5. You get the idea, okay? So you can do that for all the numbers as long as you stop at 10 because he only has 10 candles. Okay, so when you graph this out, this will be just a quadrant 1 graph. Quadrant 1 is just the upper right-hand corner of a graph. When you have all 4 quadrants, this is 1, 2, 3, and 4. Now, quadrant 1, the x is positive and the y is positive. So in this case, our x is going to be number of candles. So we're going to track as he sells these candles, we're going to look and see, well, what happens? How much money does he get? Now, hopefully you see somewhat of a trend. What's happening as we sell more candles? Yeah, the money is increasing. The more you sell, the more money you make. I hope that's obvious. If it's not, I'm really sorry. It should be. So when we do this, we've got, 1, 2, 3, 4, 5, 6, 7. We'll do a couple, kind of get a basic trend. If you go all the way out to 10, you have to stop at 10 because that's all he has. He only has 10. And I'll go ahead and do that real quick. I'll extend this out, 8, 9, 10, so you can see what I'm talking about. There we go. So let's make this, we'll go by 5. So 5, 10, 15, 20, and 25. Okay? Now remember, if he sells 0 candles, he's not going to make any money. If he sells 1 candle, he's going to get exactly $2.50, which is halfway between 0 and 5. Okay? So you go halfway. If he sells 2 candles, he's going to get $5. 3 candles, $7.50. 4 candles, we're up to $10. And you can see we're developing this pattern here as we're going up. So do the points. More money is being made until when we get to $10, we're going to have, or 10 candles, we're going to have $25 made for the school. Now, should I connect this with a line? Now think about it really carefully. Number of candles. This is the question I ask myself. If somebody came up to me and I had a jar with a candle in it, could I sell them half that jar? The answer is no. They either buy that jar with the candle in it or they don't. They either buy the candle or they don't. That's always discrete. Okay? That is always discrete. Now, anytime you're tracking changes over time, that's always going to be continuous. So time is continuous, and if you're counting something like number of candles, that's going to be discrete. Now, hopefully I made that really simple for you. All right, I've got a little code word for you. A review from chapter 2, conjunctions. When you graph conjunctions, they must always do what on a graph? Write that word in the bottom right-hand corner of this page so I can see it, okay? Conjunctions, when you graph them, must always do what on the graph? All right, good job. So here we are, we're back to letter B. Angelique's heart rate is being monitored while she exercises on a treadmill. While walking, her heart rate remains the same. As she increases her pace, her heart rate rises at a steady rate, and when she begins to run, her heart rate increases more rapidly and then remains high while she runs. As she decreases her pace, her heart rate slows down and returns to her normal rate. Okay, notice that they did not give us any numbers. Letter A, if we got numbers, we could actually figure out the exact answer for all of this, and which is great. Sometimes you can do that. Sometimes you just have pretty vague information. Grab that highlighter that you were using for example 1. Let's grab that, and let's see if we can highlight the key pieces of this graph. So we know she's being monitored while she's exercising on a treadmill. She's walking, and her heart rate remains the same. Now think about it for just a second. Remains the same. All right, is it going up? No. Is it going down? No. Remaining the same. Think about it. What would that look like on a graph? Okay, if you are thinking and screaming at the screen, it's horizontal. You're exactly right. Horizontal line. Okay, next she's increasing her pace, so she's walking faster. Now her heart rate rises at a steady rate. So rises, already we can see the picture on the graph. We go from a horizontal line to a line that's starting to go up. Now she's running. Her heart rate increases more rapidly, okay? And then remains high while she runs. So we have a little bit more of a steadier, stronger increase, and then she stays at that high for a little while. Okay, now she's starting to slow down, so her heart rate slows down and returns to her normal rate. Okay, that's really interesting. We've got some great information here. It looks like we've got 1, 2, 3, 4, 5, 6 pieces that we're going to need to graph here. All right, so switch back to your pencil. We're ready to put this on a graph. We are studying how her heart rate changes as time goes by. Okay, so let's do this. Let's do heart rate here on the y-axis, and let's do time on the x-axis. Okay, we just picked it apart. Now her heart rate, I can already tell you, if her heart's beating, we're not going to start at 0. If you have a 0 heart rate, that means you are dead. So we're not starting at 0. I don't know where we're starting specifically. They didn't give us an exact number, which is fine, but we're not starting at 0, okay? So let me make that implicitly clear. All right, so heart rate remains the same. So our first stroke should be horizontal line, not at 0, so somewhere above 0, okay? So we got that part done. Heart rate remains the same. Now she's walking faster, so her heart rate rises steadily, okay? So there we go, it's going up steadily. Now she's starting to run, so her heart rate's going even faster, so make that a little bit steeper line, and then it's going to stay there high while she runs, okay? Then it's going to slow down, which means it's going to go back down, and it's going to return to her normal rate. Here and here. So do you see your 6 pieces? 1, 2, 3, 4, 5, and 6. And that's really the best representation. You want to include every little piece of this so it makes, so you can track it on your graph. Okay, I don't have any extra credit for you, I'm sorry, but I did have a code word for you, so if you missed it, rewind me. I said it between A and B, okay? Thanks for listening, and bring your questions to class.